Hello dear students, this is Sandhya BJ, Department of Chemistry, SJPNPU College, Nitsusi. I am doing the topic about haloalkanes and haloarenes, completed with the topics Introduction to haloalkanes and haloarenes, Classification, Nomenclature, Nature of CX bond, Methods of preparation, Physical properties, and in the chemical properties, in my last class I have completed the SN1 reaction, SN2 reactions with their mechanisms, along with that stereochemical aspects of the nucleophilic substitution reactions. Right? Today I am telling you about some important aspects regarding the reactions. Okay? First, here is one question arise. In SN1 reaction, if the nucleophile attacks the stereo center, the product formed will be the racemic mixture. Give reason. So, what you have to do? First, in the SN1 reaction, what happens? There arise a two-step reaction, right? In the SN1 mechanism, we have seen that two-step mechanism. SN1 reaction is a two-step mechanism. So, what happens in the first step? There will be a formation of the carbocation, right? In the first step during the SN1 reaction, what happens? There will be the formation of the carbocation. So, in SN1 mechanism, the first step involves the formation of carbocation. Here, the carbon atom containing positive charge in carbocation is sp2 hybridized. So, here comes the sp2 hybridized. In your previous year classes, you have learnt about this sp2 hybridization, right? Mixing of 1s orbital and 2p atomic orbitals to form a 3 hybrid orbitals. This is the sp2 hybridization. Here what happens? The formed carbocation. In the first step, the formation of carbocation is there, right? That carbocation has a sp2 hybridized carbon atom. Hence, the carbocation will have a planar structure. Therefore, the nucleophile can attack this planar carbocation from any one of the direction. Avaga enagutte nucleophile yadu OH minus agirbodu. For example, OH minus tagolna, it is a nucleophile. It can attack at both the side of the carbocation, right? Because of its planar structure. Hence, there will be a formation of the racemic mixture, that is D and L isomers, right? D and L, or plus and minus, 50% of D isomer and the 50% of L isomer forming the racemic mixture. For example, 2-bromobutane on heating with aqueous solution of sodium hydroxide gives a racemic mixture containing 50% of dextrobutane toluol, that is D-butane toluol. D anta andre positive, right? And 50% of L-butane toluol. Hence the mixture is called as D and L butane toluol. Here you can see the reaction. 2-bromobutane, right? 2-bromobutane na tagondu first step SN1 reaction alli enagide illi carbocation has been formed, right? Carbocation formation agutte. So Br minus idu eliminate agutte in the first step of SN1 reaction, followed by what happens? Followed by there will be an attack of nucleophile here. Here you can see the attack of nucleophile, right? Either the nucleophile can attack from this side, or the nucleophile can attack from this side, right? So there will be a formation of minus butane toluol and plus butane toluol. E kade adre, e side inda adre it forms a minus butane toluol, and e side adre what happens? It is a plus butane to all. Next is another one question. In SN2 reaction, if the nucleophile, for example OH minus, attacks the stereo center, then the inversion of the configuration across the stereo center takes place. Why? In the SN2 reaction, it going to form an inversion of configuration, right? Andre for example umbrellana windige ಹಿಡಿದಾಗ ಏನಾಗುತ್ತೆ ಉಲ್ಟಾ ಆಗುತ್ತೆ ಆ ತರ ಕಾನ್ಫಿಗರೇಷನ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ ಇರೋದು. Why it is like that? Means during the SN2 mechanism, the nucleophile attacks the stereo center from the side opposite to the halogen atom, right? X ಅಂತ ಹೇಳ್ಬೋದು. X ಅಂದ್ರೆ halogen atom ಇಂದ opposite side ಅಲ್ಲಿ ಅದು ಏನಾಗೋದು ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ ಇನ್ವರ್ಷನ್ ಆಫ್ ಕಾನ್ಫಿಗರೇಷನ್ ಟೇಕ್ಸ್ ಪ್ಲೇಸ್. ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಸಿ ವೆನ್ -2 ಬ್ರೋಮೋ ಆಕ್ಟೇನ್ ಇಸ್ ಹೀಟೆಡ್ ವಿತ್ ಅಕ್ವಿಯಸ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ NaOH ನ ತಗೊಂಡಾಗ OH ಇದೆಯಲ್ಲ ದಟ್ ವಿಲ್ ಆಕ್ಟ್ ಆಸ್ ಎ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಪ್ಲಸ್ ಆಕ್ಟೇನ್ 2ol is formed. Here you can see the minus is going to form a plus octane 2ol is formed. Here the OH group occupies the position opposite to that of the bromine. Bromine ಗೆ opposite side ಅಲ್ಲಿ. Hence inversion of configuration will takes place. Here you can see ಇಲ್ಲಿ bromine ಇದೆ, right? ಇಲ್ಲಿ bromine ಇದೆ. ಇದು SN2 ಆಗಿರೋದ್ರಿಂದ ಸಿಂಗಲ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ, right? SN2 mechanism involves only one step. So ಈ ಬ್ರೋಮಿನ್ ಈಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಯಾವುದು OH minus is a nucleophile. When it comes and attacks this place, the bromine will be eliminated as a bromide ion ಅಥವಾ halogen will be eliminated as a halide ion ಅಂತ ಹೇಳ್ಬೋದು. Here you can see the -2 bromo octane is going to form a plus octane 2ol. So inversion of configuration ಆಗಿದೆ, right? ನೋಡಿ ಇಲ್ಲಿ ಇದು ಯಾವುದು ಡ್ಯಾಶ್ಡ್ ವೆಡ್ಜ್ ಈ ಕಡೆ ಬಂದಿದೆ, ನೆಕ್ಸ್ಟ್ ಸಾಲಿಡ್ ವೆಡ್ಜ್ ಈ ಕಡೆ ಬಂದಿದೆ. ಸೊ ಇನ್ವರ್ಷನ್ ಆಫ್ ಕಾನ್ಫಿಗರೇಷನ್ ಆಗಿದೆ. ನೆಕ್ಸ್ಟ್ ಈಸ್ ಡಿಹೈಡ್ರೋಹ್ಯಾಲೋಜಿನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಆರ್ ಬೀಟಾ ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್. ಅಂದರೆ ಯಾವ್ದು ರಿಯಾಕ್ಷನ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿದೆ ಈ ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಲ್ಲಿ ಅಂತ. ಬೀಟಾ ಎಲಿಮಿನೇಷನ್, ರೈಟ್? When alkyl halide with beta hydrogen atom is heated with alcoholic potash, here comes the word beta hydrogen atom andre ಏನು, right? For example, here you can see one example, right? ಇದಕ್ಕೆ ಒಂದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅಟ್ಯಾಚ್ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. X is a functional group. So ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದೆ, here also hydrogen is there, hydrogen, here also hydrogen is there. So what happens, ಡೈರೆಕ್ಟ್ ಆಗಿ ಅಟ್ಯಾಚ್ ಆಗಿರೋದು ಯಾವುದು ಕಾರ್ಬನ್, ಇದು ಯಾವುದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪಿಗೆ. ಸೊ ದಿಸ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆ್ಯಂಡ್ ಅದಕ್ಕೆ ಇರೋವಂಥ ಹೈಡ್ರೋಜನ್ನ ನಾವು ಆಲ್ಫಾ ಹೈಡ್ರೋಜನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಅಡ್ಜಸೆಂಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂದರೆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಪಕ್ಕ ಇರೋವಂಥ ಕಾರ್ಬನ್ ಆಟಮ್ನ ನಾವು ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ಕರಿತೀವಿ. ದೆನ್ ದ ಹೈಡ್ರೋಜನ್ ಅಟ್ಯಾಚ್ ಟು ದ್ಯಾಟ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ beta hydrogen atom, right? These two are beta hydrogen atom, okay? And adjacent carbon atom andre idu barutte. Next idru pakka irodunna navu gamma carbon atom anta heltivi, and the hydrogen attached to that hydrogen atom is called as gamma hydrogen atom. I think you all have clear what is the meaning of an beta hydrogen atom, right? So when an alkyl halide with beta hydrogen atom is heated with the alcoholic potash andre KOH, potassium hydroxide, there is elimination of the hydrogen atom from the beta carbon atom and a halogen atom from the alpha carbon atom. ಏನಾಗುತ್ತೆ, ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ನಲ್ಲಿರುವಂಥ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಯಾವುದು ಹ್ಯಾಲೋಜನ್ ಇದೆ ಇಲ್ಲಿ, ಇಟ್ ವಿಲ್ ಆಲ್ಸೋ ಎಲಿಮಿನೇಟ್ and ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಕೂಡ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಬೀಟಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅಥವಾ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಎಲಿಮಿನೇಟ್ ಆಗಿರೋದ್ರಿಂದ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೀಟಾ ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಹೈಡ್ರೋಹ್ಯಾಲೋಜಿನೇಷನ್. ಹೈಡ್ರೋಜನ್ ಒಂದು ಎಲಿಮಿನೇಟ್ ಆಗ್ತಿದೆ, ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ಹ್ಯಾಲೋಜನ್ ಒಂದು ಎಲಿಮಿನೇಟ್ ಆಗ್ತಿದೆ, ರೈಟ್. ಆಸ್ ಅ ರಿಸಲ್ಟ್ an alkene is formed as a product. ಆಲ್ಕೀನ್ ಅಂದರೆ ಡಬಲ್ ಬಾಂಡ್, ಸಿ ಡಬಲ್ ಬಾಂಡ್ ಸಿ ಇರುತ್ತಲ್ಲ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆಲ್ಕೀನ್. Since beta hydrogen atom is involved in the elimination reaction, it is called as beta elimination. Okay, it is called as beta elimination. Yes. Here you can see the beta elimination. Example of an beta elimination. ನೋಡಿ ಇಲ್ಲಿ ಇದನ್ನ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತೀವಿ. This is an ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್. ಈಗ ಆಲ್ಕೋಹಾಲಿಕ್ ಪೊಟ್ಯಾಶ್ ಅಂದರೆ OH ಬೇಸ್, ಬಿ ಅಂದರೆ ಇಲ್ಲಿ ಬೇಸ್ ಹೋಗಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ನ ಅಟ್ಯಾಕ್ ಮಾಡಿ ಏನಾಗಿದೆ ಅಲ್ಲಿ, ಇಲ್ಲಿ ನೋಡಿ ಈ ಥರ ಮೂಮೆಂಟ್ ಆಗಿ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ದ ಆಲ್ಕೀನ್ ಹ್ಯಾಸ್ ಬಿನ್ ಫಾರ್ಮ್ ಹಿಯರ್. ದ ಲಿವಿಂಗ್ ಗ್ರೂಪ್ ದಟ್ ಈಸ್ ಹ್ಯಾಲೋಜನ್ ಆಟಮ್ ಆ್ಯಂಡ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಹ್ಯಾಸ್ ಬಿನ್ ಎಲಿಮಿನೇಟೆಡ್. ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ BH ಅಂದರೆ ಬೇಸು, OH ಮತ್ತು H ಸೇರಿಕೊಂಡ್ರೆ H2O ವಾಟರ್ ಫಾರ್ಮೇಷನ್ ಆಗಿದೆ, ರೈಟ್. ಆ್ಯಂಡ್ ಹ್ಯಾಲೈಡ್ ಅಯಾನ್ ಈಸ್ ಎಲಿಮಿನೇಟೆಡ್. ಸೊ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಡಿಹೈಡ್ರೋಹ್ಯಾಲೋಜಿನೇಷನ್ ಆ್ಯಂಡ್ ಆರ್ ಬೀಟಾ ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್. ಏನಕ್ಕೆ ಬೀಟಾ ಎಲಿಮಿನೇಷನ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಅಂದರೆ, ಬಿಕಾಸ್ ದ ಬೀಟಾ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಅಂದರೆ ನೋಡಿ ಇಲ್ಲಿ ಸಿ ಮತ್ತು ಎಕ್ಸ್ ದಟ್ ಈಸ್ ಅ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್, ರೈಟ್. ದಿಸ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಆಲ್ಫಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಆ್ಯಂಡ್ ಅದ್ರ ಪಕ್ಕ ಅಂದರೆ ಅಡ್ಜಸೆಂಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇರುತ್ತಲ್ಲ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್, ರೈಟ್. ಹಿಯರ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ದ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿ ಅಟ್ಯಾಚ್ ಆಗಿರುವಂಥ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಎಲಿಮಿನೇಟ್, ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಅಟ್ಯಾಕ್ಡ್ ಬೈ ಆನ್ ಆಲ್ಕೋಹಾಲಿಕ್ ಪೊಟ್ಯಾಶ್ ಆ್ಯಂಡ್ there will be a removal of the halide group. So this is the beta elimination reaction. Next is about the Said-Safe rule. Said-Safe ಅನ್ನೋ ಒಬ್ಬರು ಸೈಂಟಿಸ್ಟ್ ಮಾಡಿರುವಂಥದ್ದು. It states that during dehydrohalogenation reaction or beta elimination reaction of alkyl halides, if more than one type of beta carbon atoms are present, for example ಇಲ್ಲಿ ನೋಡಿ ಬರೀ ಇದೇ ಥರ ಇರಲ್ಲ ನಮಗೆ ಕಾಂಪೌಂಡ್ಸ್, ಆರ್ ಇಟ್ ಕ್ಯಾನ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಲೈಕ್ ದಿಸ್ ಆಲ್ಸೋ ಅಲ್ವಾ, ಇದೇ ಥರನೂ ಇರುತ್ತೆ. ಸೊ ಇದು ಆಲ್ಫಾ ಆಗುತ್ತೆ, ಇದು ಬೀಟಾ ಆಗುತ್ತೆ, ಇದು ಬೀಟಾ ಆಗುತ್ತೆ, ರೈಟ್. So if there is a presence of more than one type of beta carbon atoms, hydrogen atom must be removed from the beta carbon atom containing least number of hydrogen atom. Hence highly substituted alkene is formed as the major product. ಏನಾಗುತ್ತೆ ಅಂದರೆ ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿ ಯಾವುದರಲ್ಲಿ ಕಮ್ಮಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇರುತ್ತೆ ಆ ಹೈಡ್ರೋಜನ್ ಆಟಮ್, ಆ ಕಾರ್ಬನ್ ಆಟಮ್ನ ನಾವು ಬೀಟಾ ಎಲಿಮಿನೇಷನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ದಟ್ ಈಸ್ ಅನ್ Said-Safe ರೂಲ್. ಹಿಯರ್ ಈಸ್ ಒನ್ ಎಕ್ಸಾಂಪಲ್. 2-bromopentane gives pent-2ene as the major product. ಇದರಲ್ಲಿ ಎರಡು ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಓಕೆ, ಎರಡು ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ, ಯಾಕೆಂದರೆ ಎರಡು ಬೀಟಾ ಕಾರ್ಬನ್ ಆಟಮ್ ಪ್ರೆಸೆಂಟ್ ಇರುವಂಥ ಎರಡೂ ಕಡೆಗೆ ಆಗುತ್ತೆ ಯಾವುದು ಅಟ್ಯಾಕ್, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. Whereas ಅದರಲ್ಲಿ ಮೇಜರ್ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ pent-2ene. Here you can see this is a alpha carbon atom, this is a beta carbon atom, this is also a beta, this is gamma, this is delta, right. ಇದನ್ನು ಬೀಟಾ ಅಂತ, ಇದನ್ನು ಬೀಟಾ ಅಂತ ಹೇಳ್ತೀವಿ, ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. This is also can be considered as a beta. So according to the Said-Safe rule, what it has told, beta carbon atom containing least number of hydrogen atoms. So here you can see the idukke ನಾವು this will give a major product. It will also attack by a nucleophile, whereas this gives a major product. So here you can see ಇಲ್ಲಿ ಇರುವಂತ ಹೈಡ್ರೋಜನ್ ಎಲಿಮಿನೇಟ್ ಆಗಿ H2O ಫಾರ್ಮೇಷನ್ ಆಗಿದೆ, KBr, okay, potassium bromide, and pent2ene. This is a major product. This is one reaction, and there will be another one reaction that will give a minor product. ಅಂದ್ರೆ ಇಲ್ಲಿಗೆ ಆಗಿರುವಂತದ್ದು, okay, ಇಲ್ಲಿರುವಂತ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಮೇಲೆ ಆಗಿರೋದು. ಸೊ ದಿಸ್ ವಿಲ್ ಗಿವ್ ಅ pent1ene. ಇಲ್ಲಿ pent2ene ಏನಕ್ಕೆ ಅಂದ್ರೆ 1 2 3 4 and 5, right? So second position ಅಲ್ಲಿ alkene ಇರೋದ್ರಿಂದ pent2ene, and here also 1 2 3 4 and 5. First position ಅಲ್ಲಿ ನಮಗೆ double bond ಇರೋದ್ರಿಂದ it is a pent1ene, and potassium bromide along with that water is formed. So major product according to the Sadzeff rule, the beta carbon atom which contains the least hydrogen atom will give a major product. This is the Sadzeff rule. Next is the reaction with metals. How the haloalkanes will react with metals to give a product. Organometallic compounds. Organo ಅಂತ ಅಂದ್ರೆ CH, ಅದ್ರ ಜೊತೆ ಇನ್ನೊಂದು ಯಾವ್ದಾದ್ರು ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ಬೋದು, ರೈಟ್? ಅಲಾಂಗ್ ವಿತ್ ದಟ್ ಕಾರ್ಬನ್ನಿಗೆ ಒಂದು ಮೆಟಲ್ ಬಾಂಡ್ ಆಗಿರೋದನ್ನ ಆರ್ಗ್ಯಾನೋಮೆಟಾಲಿಕ್ ಕಾಂಪೌಂಡ್. ಕಾರ್ಬನ್ ಅಂಡ್ ಮೆಟಲ್, ರೈಟ್? ಕಾರ್ಬನ್ ಅಂಡ್ ಮೆಟಲ್ ಬಾಂಡ್ ನಾವು ಆರ್ಗ್ಯಾನೋಮೆಟಾಲಿಕ್ ಕಾಂಪೌಂಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಓಕೆ? Organohalogen compounds react with certain metals to give compounds. Organohalogen compounds, that is RX, will react with certain metals to give compounds containing carbon metal bonds, that is RMX. ಅಂದ್ರೆ ಇದು RM ಇದೆಯಲ್ಲ, that is a carbon and metal bond, that is known as organometallic compound. ಈ organohalogen ಏನಿದೆ RX will react with the metal to give a compounds containing carbon metal bond, that is called as organometallic compound. Grignard reagent, Victor Grignard ಅನ್ನೋ ಒಬ್ಬರು scientist has prepared this RMGX, that is a Grignard reagent. By using the metal magnesium, he has prepared one reagent, and the name of the reagent is Grignard reagent. So what happens during this reaction? Here you can see R means alkyl or aryl, and X means halide ion, and Mg is a metal, that is magnesium. Alkyl or aryl magnesium halides are called as Grignard reagent. RMGX ನ ನಾವು Grignard reagent ಅಂತ ಹೇಳ್ತೀವಿ. ಇಲ್ಲಿ R ಅಂದ್ರೆ carbon containing compound, Mg is a metal, so carbon and metal bond has been formed. This is a Grignard reagent. An important class of organometallic compounds discovered by Victor Grignard in 1900 is alkyl magnesium halide. This is an alkyl magnesium halide, RMGX, which is referred to as Grignard reagent. In 1900 he has discovered this organometallic compound. So how we are going to prepare this Grignard reagent? When alkyl halide, that is RX, when alkyl halide reacts with magnesium, when alkyl halide reacts with magnesium in the presence of dry ether, in dry ether medium, alkyl magnesium halide andre RMGX has been formed. Okay, here you can see the reaction. RX, that is alkyl halide, when reacts with magnesium in dry ether medium, RMGX, that is Grignard reagent, has been formed. Here this is one example, ethyl bromide is treated with magnesium in the dry ether medium to form a ethyl magnesium bromide. This is an organometallic compound example. Next, Grignard reagents are highly reactive and react with compounds containing active hydrogen. Usually, Grignard reagent they are highly reactive compound and they are going to react with the compounds containing hydrogen. For example, water, alcohols, amines, adralliruvanಥ hydrogen ಜೊತೆ ಬೇಗ react ಆಗುತ್ತೆ. So, to give a hydrocarbons. So, what happens? We are going to use a dry ether, right? Dry ether ಇಲ್ದನೆ ಹಾಗೆ ನಾವು ಮಾಡೋದಕ್ಕೆ ಹೋದ್ರೆ in case of any small amount of moisture is present, okay, in case any small amount of moisture is present, it going to react with that and to form a hydrocarbon. So hence the medium should be dry and inert. Therefore inert solvent like dry ether is preferred. See, RMJX in case another water content idre RH which is a hydrocarbon, right? RH, for example CH3MgCl, okay, CH3MgCl, MgCl, when it is in the presence of water, in case water content another moisture another present idre, it will form a methane, right? Magnesium hydroxide halide agutte, magnesium hydroxide chloride formation agutte adar jote along with that. So in this will give a hydrocarbon if there is a presence of water medium or alcohols, amines, etc. So in order to avoid that, we are going to use a dry ether as a medium. Next is about the Wirtz reaction. Wirtz reaction. In this reaction, when two molecules of alkyl halides react with the sodium metal in dry ether medium, here also they are going to use a dry ether as a medium. Higher alkanes are formed. This reaction is called as Wirtz reaction. In that Grignard reagent, we are going to use a magnesium, right? The metal magnesium, whereas in the Wirtz reaction, alkyl halide is treated with the sodium metal and it is also in the dry ether medium to give a higher alkanes. This reaction is called as Wirtz reaction. Here are some examples. ನೋಡಿ ಇಲ್ಲಿ ಎರಡು RX, right? ಅಂದ್ರೆ alkyl halide ನ ಎರಡು medium ಅಲ್ಲಿ ತಗೊಂಡಿರೋದು. When two molecules, right? When two molecules of alkyl halides, these two molecules of alkyl halides is treated with the sodium metal in the presence of dry ether to form a higher alkanes. So it will give a sodium halide. And here is one example. Chloromethane is treated with sodium in presence of dry ether medium. Ethane is formed, that is a higher alkane. Along with that, sodium chloride is present. So these are the different reactions involved in the nucleophilic substitution reactions. During these reactions, these are the different reactions, right? So I think you have understood what I have told today, right? One is Wirtz reaction, another one is Grignard reagent. About the Grignard reagent I have told today. Reaction with metals, organometallic compounds. Adralli Grignard reagent ಒಂದು, Wirtz reaction ಒಂದು. Grignard reagent is with the magnesium metal and the Wirtz reaction is with the sodium metal. And about the Sedgwick rule I have told. Then beta elimination reaction. So these are the different reactions involved. And if you have any doubts, you can clarify with the same. Thank you for watching the video.